Thank you, Danielle. Ed Williams speaking here. Old and gray, I've been doing simulation for 35 years now, including a lot of warehouses, and 35 years is about half my total lifetime so far. So looking back at projects and looking ahead at new projects to come, we'll take a look at the challenges and the talents that simulation software brings to meet those challenges. What are some of the benefits? And a quick look at several case studies. So here's some of the challenges. Well, the bride wants special china, not just any. How long is it going to take you to find that? The big boss, your inventory can't get any higher, sarcasm. The roof is in the way. The transport provider, you mean you haven't unloaded, whatever the vehicle is yet? Well, there's always the demurrage charge to pay us. That can eat you alive. And as these pictures, many times when I go into a warehouse and how can we make this more efficient, this is the sort of tacit message I get from things. They may be boxcars, ships, trucks. Unload me. I need to be on my way to other places. And some of the other challenges. Well, we planned for last Tuesday. You said you'd take delivery then. I don't want the strawberries have a white fur coat. I don't want them anymore. And the same boss who complained about the inventory, our customers are screaming at me, not another stock out. Forklift drivers, a whole crew of them. Well, all the forklifts can't go into that one aisle at the same time. We don't fit. And the AGV mechanics, well, of course we're forever recharging the batteries. We're at the recharging station more than we're on the floor with those routes you've laid out. So those are some of the challenges. You might even call them headaches. So those are, conceptually, there's some of the very good reasons and provocations to simulate. Simulation can reduce time by avoiding layout mistakes and avoiding design mistakes. That's at the very beginning. And ongoing during operation of the warehouse, which may be over a period of many years, simulation can avoid and correct operational mistakes with much better alternatives. You all want to lower the costs. Well, if you reduce the picking time, if you get the trade-off between no stockouts and low inventory just right, fine-tune that trade-off, that will certainly reduce costs a lot. And the more you minimize material handling, the more you get that down, the more you get your costs down. And not to mention, if you minimize material handling, you minimize the risk of breakage, accidents, misfiling. The less often you touch the crate, the less often something can go wrong. So simulation can be a big help in a lot of these ways. So when do you simulate? Well, throughput can certainly be affected by equipment reliability and availability. And the idea of the warehouse is to get things in and out, not just keep things. A warehouse is not an attic where you keep things forever and ever. If processes exhibit high variability, such as picking times, delivery times, frequency of orders, frequency of deliveries, simulation is superbly equipped to handle and analyze high variability. High variability can be built right into the model for the benefits of statistical analysis. If there's a lot of interdependence, and many times I see this if a warehouse uses more than one type of material handling equipment, such as there's some AGVs, automatic guided vehicles, there's some forklift trucks, there's some conveyors. The basic textbook statistics for the first semester of statistics assume independence, but simulation is very good not only at exposing interdependence, high correlation, but at handling it analytically to find the best alternatives. And really, the best time of all to simulate, it's actually the most challenging because the data is most uncertain and often still to be determined. But the highest rate of return on investment in a simulation project typically comes when the warehouse is drawn on a scrap of paper or the back of a cocktail napkin. That's the time for maximum return on investment, savings the simulation can produce by correcting deficiencies early, even before the first cement is poured. And now maybe there's other planets where you don't have these competitive pressures, but I'm assuming that everyone on the audience is on this planet, the third one out from the sun, where there is a lot of competitive pressure. The simulation can help you handle that pressure. Won't make it go away, it's always there, but simulation will help you stand right back up to it. So when to simulate? Well, there may be a high degree of interaction. There's that word interdependence again, between the workers and the material handling equipment. There may be various possibilities, and those possibilities or probabilities may vary by time or shift. Time might be time of day, season of the year, and so forth, resource shortage, and blockage. The storage requirements may be very unpredictable, depending both on deliveries that are unpredictable and consumer demand downstream that's unpredictable. Simulation can help with that. If there's frequent product changes, there might be danger of obsolescence, or in the case, for example, of food warehouses, that's some of the ones I've modeled, there's danger of spoilage. Well, that's like the strawberries. We don't want them to grow a white fur coat. It's hard to sell them then. So getting a bit more specific as we go along, here's some particular questions that users have asked us for guidance on out of the simulation model. Where should we put things? For example, should things be loaded in such a way that on incoming delivery, things that come in together are stored close together? Or should it be the opposite, that on outgoing, when we're picking, and in what order should we pick, things that we're likely to pick at the same time are stored close together, even if they didn't come in at the same time. So the answers to the two questions, what came in together, what goes out together, may not be the same answer. How many forklifts should we have? How many AGVs? What should their capacity be? What should their routings be? Conveyor types. How big should the conveyors be? How much money should we invest in having a faster conveyor? Where should the conveyors be located? What priorities for unloading and loading? Well, maybe the box car I showed you wants to be unloaded, the truck wants to be loaded. Which is more urgent? Staffing levels. They may profitably change by time of day, almost certainly, time of year, day of week, and so forth. And a more specialized one that comes up less often, but is important when it does come up. If you have bridge cranes, more than one in a bay, which crane, if either, should have bump away priority? against the other crane. Now, simulation software in the last few years has gotten enormously more powerful. The run speed has greatly improved. Partly that's because of hardware advances, and partly because the simulation software is getting fine-tuned in terms of running speed. And typically nowadays, when you build a simulation model, or when we build it for our client, the animation is built right along with the model at certainly less than 5% incremental effort. And the overhead to get from a two-dimensional to a three-dimensional animation is, with many softwares now, the overhead is only 2 clicks of the mouse. And one software I use often, I counted the mouse clicks. There were 2. And a lot of simulation software has stronger and more convenient, nowadays, statistical analyses available to let you run multiple alternatives, one after the other, all with one mouse click. The first one runs and the second one runs. An output report is automatically produced with performance metrics for all the different situations you want to try out so that they can be compared. And confidence intervals will appear on demand. And box and whisker plots will appear one mouse click away. That amounts to saying the routine statistical practice of building confidence intervals for performance metrics, or confidence intervals for the difference in a performance metric between 2 alternatives, is very close to being fully automated. Now, for more complex situations, when power like design of experiments is needed statistically, then admittedly a specialized statistical package is needed. And it's typically routine to export the simulation results to a spreadsheet from which they can be imported to a heavy-duty statistical package to do things like analysis of variance or design of experiments. So again, looking at it conceptually, we've got a problem coming up here, and the time to fix it is on the computer animation screen. And simulation animation will bring up a big red X here. No, we don't want them to crash into each other. That's a lot cheaper, a lot safer, and a lot quicker than finding the problem on the warehouse floor. Whoops, we forgot about that blind corner. So wrong versus right simulation and its animation is a big improvement here. Also, at a more experienced level of user, when the time comes, simulation software nowadays is increasingly customizable. Now, that's usually not what a new client wants to do at first. But if and when the time comes, custom components can be built and there's good modeling power quickly, even for a relatively new user. And then, like the hockey stick, the modeling power goes up very rapidly when there's a real expert involved. Now, some of our clients want us to build the models and show them the results and help with interpretation. A few clients are going to be modeling so often that they use us as a starting point for building up heavy-duty modeling expertise. That's worth doing if your company or business is going to have a lot of modeling to do, enough that it's worth investment in developing your own expertise in 1 or 2 in-house experts. And likewise, simulation software, nowadays all the packages will talk nicely, getting input from and output to an Excel workbook. And most of them will work nicely with talking to a database. It's often Microsoft Access, but it doesn't have to be. And process control systems, which produce reports like frequency of AGV or forklift travel, can be customized to make interface and produce data for the simulation software to use. And the simulation animation can easily be constructed with several views. An overall view of the warehouse floor, another magnified view looks at Department A versus Department B versus aisles 8, 9, and 10, and it's one mouse click for the person looking at the animation to move from one to the other. And in general, simulation software is much more run by the mouse with much less keyboarding to model, say, queuing or priority disciplines that are other than the standard first come, first serve, or a basic prioritization level. So here's one of the case studies promised you. We worked on, this was 2 automotive assembly plants and 1 component fabrication plant, which collectively, the component fabrication sent things to the 2 assembly plants. And the linkages between them were public transport, by truck or by rail. So the simulation model we built contained all 3, the 3 plants, plus it contained the logic involved in the linkages, and here are the things we optimized. It saves a lot of money not to have unnecessary loading docks. The turnaround areas were reduced without any bad impact, and every square yard costs money. And the inventory level was lowered, and the distribution of containers was made, shall we say, smoother, less variable. You didn't want all the containers to end up accumulating at any one of the 3 places. Well, here's a secondary case study. This was an appliance manufacturer. Think freezers, stoves, refrigerators, dishwashers. They're big and bulky. So too many stock keeping units, too much inventory is a big expense. And there's safety issues moving and sorting and stacking these heavy bulky crates with appliances inside them. The warehousing took place just down from the assembly line. And when the client came to us, the assembly line actually had to stop a couple of times per calendar quarter because the warehouse was jammed full right downstream from the assembly line. And we did get that down. We got that down to 0. That was a good number for the number of blockages. We ran the simulation model for a simulated year, no blockages, and the client has happily told us when they came back for a different project, the client happily told us, well, it's been 2.5 years now and we have not had another blockage. And here was a more consumer-oriented warehouse which received input from many different factories, shrink-wrapped them protectively, put them away in the warehouse, and then different retail chains, things like Target, Walmart, Kmart, would call for the products they needed, and the correct shrink-wrap containers had to be picked and sent out. This was a 2-story warehouse, so there was a freight elevator, certainly, and we helped the client get the truck turnaround way down by more than 50%. That was a big help. It was very good for relationships. The warehouse obtained more storage business because the retail chains were happy, and the arriving trucks did not have to line up waiting for a loading dock. That made everybody happier. And that was done by changing the location of the stretch wrap machines and where the shrink-wrapped orders were placed in the outbound storage for upcoming picking. So there are some enticing thoughts for potential new users of simulation.